Hypertension, how high blood pressure can affect your body and how your body maintains homeostasis of blood pressure. Today I'm going to be talking about blood pressure, which is the pressure of the blood pushing against the walls of your arteries, and from there the arteries carry the blood from the heart to the rest of your body. A regular blood pressure reading is 120/80.
Today, we're going to be talking about respiratory acidosis. Our bodies are the happiest when our blood pH is between 7.35 and 7.45. Our respiratory, circulatory, and urinary systems all work together to maintain and achieve this happy parameter. When we are in this happy parameter, we are in our body's favorite state called homeostasis. But sometimes our blood pH goes down and becomes acidic, and sometimes it goes up and becomes more alkaline than normal. This throws our body out of homeostasis. One condition that we can develop is respiratory acidosis. As mentioned, our bodies are happiest in homeostasis, but disturbances can occur. With respiratory acidosis, our partial pressure of carbon dioxide, abbreviated PCO2, is elevated due to hypoventilation. Hypoventilation causes our PCO2 levels to rise because we are not having an adequate amount of respirations to expel our CO2. This results in our blood pH lowering and becoming acidic. Our bodies sense this change in homeostasis, and our arterial and cerebrospinal fluid chemoreceptors spring into action. Our body tells us to increase our breathing rate, which will help us expel our extra carbon dioxide. Our kidneys will secrete hydrogen ions and start to generate bicarbonate. Our body's other buffering systems, besides our carbonic acid and bicarbonate system, will accept the extra hydrogen ions. The amount of hydrogen ions present in our blood will decrease, and our bicarbonate levels will increase. The respiratory, circulatory, and urinary system work as a team to do all of this. And this team effort results in a decrease in our PCO2 levels. And with our PCO2 levels decreased, our blood pH will return back to 7.35 to 7.45. And this will make our bodies happy, and we will be back into homeostasis.
Today we're going to be talking about homeostasis of sodium ion concentration in the ECF, or the extracellular fluid. The normal sodium level is between 135 and 145. Those levels can then raise or drop, and that would cause a disturbance in homeostasis. When those levels have increased, so whenever sodium in the extracellular fluid has increased, our osmoreceptors are then stimulated and ADH secretion increases. Our kidneys then begin to reabsorb water, which then causes our body to become thirsty, so that way we consume more water to lower those sodium levels. Whenever we have a disturbance in the homeostasis, or our levels have either dropped or raised, our cardiovascular system has RAS activated, or renin-angiotensin-aldosterone. Sorry if I said that wrong. Which basically our blood volume and blood pressure decrease. Our urinary system eliminates waste by filtering out the excess fluids and the sodium, which is promoted whenever we are drinking the water. Our homeostasis is then restored by decreasing the amount of sodium in our extracellular fluid. Thus, a normal sodium level has been achieved. The process is similar whenever our levels drop. Whenever our levels of sodium drop, In our extracellular fluid, our osmoreceptors are then stimulated once more. ADH or antidiuretic hormone levels have begun to decrease. If the levels of ADH decrease, water loss by the kidneys increases. The cardiovascular system once more decreases the blood volume and blood pressure, and our urinary system tries to eliminate the excess water and store more sodium whenever we see this happen, thus restoring homeostasis once more with the increase of sodium in the ECF, and that normal 135 to 145 sodium range has then began to be achieved. Higher sodium levels is called hypernatremia, whereas lower sodium levels is called hyponatremia.